Hello and welcome back, friends. I'm Dr. Sally, and this is the first tutorial of LaTeX for Scientists. In this video, we're just going to jump straight in. We'll cover all the basic information you need to be able to understand how LaTeX works, how to create a simple document using the article class, and how to structure a document with additional files and a table of contents. Since this video is going to be a little bit longer, there are timestamps in the description. I'm going to use the online platform Overleaf, and I recommend you do too, because even the free version is extremely convenient. It's a fully online platform, so all your work is continuously backed up, and it makes it really easy to collaborate with your colleagues. Before you make an account, check if your university has signed up for their Overleaf Commons program. If they have, you'll get access to the professional version for free, but you'll need to use your official university email address to get it. If you've already signed up, you can always add your university email under the account settings, and as long as the email address is valid, it'll automatically upgrade for you, no problem. Honestly though, for most people the free version's more than enough. Although that being said, you can also unlock permanent bonuses on your account, like extra collaborators and Dropbox integration and so on. And you can do that by sending people your referral link and getting them to sign up with it. You can invite up to 10 people, so if you already have an account, feel free to share your referral link in the comments down below. And if you don't have an account yet, be a legend and use the link of someone in the comments, and then drop yours down there for others to use, and everybody wins. Anyway, the sign up is very easy, so I'll let you do that. And once you're signed up, log in and we'll get started. I've also made a new free account and a quick example document so I can just show you the projects page where you log into. This is basically just a list of all the active projects that you have. If any of them aren't yours, but they've been shared with you, you'll see the initials or the name of the person who shared it with you. You can see when it was last worked on, and you also have these options here on the top right: copy, download, archive, and trash. You can also select a document or documents by checking this box here on the left, and this gives the same options plus a couple of extra ones. But if you've just made a new account, you won't have anything here yet. So what you want to do is look over here on the left sidebar, click on New Project, and you'll see this drop-down menu. At the bottom here, you have a list of the most common template types, and you can click on any of these to explore the templates that other people have uploaded. There are quite literally thousands of them, and you can learn a hell of a lot by searching for templates that you like the look of and exploring the code that they've used. If you already have a template, from a journal for example, you can also upload it here in this top part. But we don't need a template, we're going straight in at the deep end and making our own. So at the top here, click on Blank Project and type in a name for it. And I'm going to very imaginatively call mine My Template. It'll take Overleaf a moment or two to load it, and then you'll be presented with a small amount of weird looking code and not the blank document you might have been expecting. And that is a good place for me to take a swift detour and give an overview of how LaTeX works and how the documents are structured. Believe it or not, LaTeX is a real programming language. You do all of your writing in a plain text file, which is conventionally called main.tex, but will always have the .tex file extension. Within your writing, you'll include additional bits of code called commands. This file is then passed into a compiler, which reads your commands and formats the writing according to them, and then creates an output file that looks nice for the reader. This is how it works at the most basic level. Seems pretty easy, right? But even if you want to make it more complicated by, say, using a set of separate text files for different chapters, or a bibliography file or style files, it's actually not any more complicated than that. All we have to do is tell the compiler, inside main.tex, where to look for each of those additional files, and it just handles everything. But I'll show you more about how that works shortly. First though, let's get back to this document that we've just created. Over here on the left sidebar, you can see that Overleaf has called it main.tex for us, which is handy. Up here you can also add new files, create folders to keep all your files organised, or upload other files like images. Any files or folders you add will be listed here in alphabetical order. And for any files that you select, you can also click on the little pencil icon to rename them, or the little bin icon to delete them. Now then, let's take our second detour to talk about the main.tex file and how it's structured. The file is composed of two main parts, the body and the preamble. The body contains all of the content that will be shown in your final document. And you'll notice these two commands here, begin document and end document. These mark the beginning and end of the body like a pair of brackets. Everything that belongs in the final output has to be placed between them. The compiler will ignore anything that comes after the end document command, and it'll assume anything that comes before begin document belongs to the preamble. The preamble contains all of the packages and commands that tell the compiler how to format the document, and commands in the body identify where the important bits are that need specific formatting. So for an example, if you have something like a section heading, you enclose it with the section command, or a tag if you prefer to think of it that way, and that tells the compiler, okay, everything inside this squiggly bracket is to be treated as a section heading. The compiler then takes that section heading and applies the formatting that you specified in the preamble. So let's just go through line by line and see if we can make sense of all these commands. We always start every document by declaring the document class. This tells the compiler which set of default formatting commands to use. If you have a class file from a journal, say, you'd declare that inside the squiggly brackets instead. Overleaf has used the article class for us, so we'll just stick with that for now. With every class and most packages, you can also select different options. And to do that, you need to insert a set of square brackets in front of these squiggly ones and declare the options that you want to use inside the square brackets. So let's say we want to make sure that we're definitely using A4 paper and that we want the default font size to be 11-point font. Next we have this weird looking thing, UTF-8 as an option to the input enc package. We actually want to type another package before this one, so we'll do \use package, font enc inside squiggly brackets, and then we'll use the option T1 inside square brackets. Now what these two packages do is they let us use non-Latin characters like Greek, or different symbols or letters with accent marks. And if you're in STEM, it's basically a given that you're going to need to use these. So next we have the title, author and date. Inside the squiggly brackets you declare the contents of whatever needs to go in your title before the document actually starts. And then you'll notice down here that we have a command inside the body called /maketitle. And what that does is make sure that the title, author and date are actually going to be printed on the page. The author and title are required fields, but if you don't want to have the date, then you can just use \date with empty squiggly brackets, and that will suppress the date being shown. So now we'll press compile to make the compiler produce a fresh output after our changes, and success! No errors. So although this very basic document works, it doesn't really look like much right now. So let's add some stuff in to give it a bit of a something. The first thing we're going to do is call a really handy package called Lipsum, which is short for lorem ipsum. And this produces a bunch of nonsense Latin text of various paragraphs that can be used to conveniently fill out a template and give you an idea of how the end document will actually look with the formatting that you've specified. So to do this, we go back to our preamble and we type in \use package and then Lipsum to load the package. Then we go to wherever we want to have a dummy paragraph, let's say underneath the introduction section heading, and type in /Lipsum and then square brackets and then a number from 1 to I think about 11. There are quite a few different paragraphs, so you can change the look of the text by changing the number inside the square brackets. Now let's add some more section headings, but we're going to get a bit fancy and use some additional files. So let's add a method section heading underneath the introduction with \section squigglies method. And then we'll go over here to the left sidebar and create a new file called method.tex. And now let's use our Lipsum command to generate a few fake paragraphs inside that file. And maybe a couple of subsections just to spice it up a bit. And then we'll hit recompile. Now you'll notice that the new section and our dummy text haven't actually appeared. And that's because we haven't told the compiler that we want to use this file or where we want it to go. So we'll do that next. So let's go back to main.tex. And let's go down here to just below our section heading. And we'll type in \input because we want to input the contents of the method file. And then we put method.tex inside the squiggly brackets. Now when we recompile, it should appear. And it does. And this is actually a really good way to keep your main.tex file nice and tidy. If you're only working on one section at a time, you can keep the rest commented out by putting a percentage symbol in front of the command, and then the compiler will skip that part and only print the bits that you want to see. This is much, much easier and less fiddly than trying to comment out all of these sections line by line. You've probably noticed, looking at how the dummy text looks on page 2, that the margins in the default article class are absolutely massive. That's because they're set to be book margins, but unless you're actually writing a book, you probably want a bit more control over how the text is presented, if only just to save on printing costs while you're working on your draft. And this is where the geometry package comes in. So let's call that in the preamble as well, with \use package, squigglies, geometry. And this package is extremely flexible and there's a lot of different options. But to keep things simple, we might just choose to have all the margins the same size, in which case we'd use the optional argument, square brackets, margin equals, let's say 1.5 centimeters. Or you might have been told what size margins to use, in which case you can specify them separately. So, for example, top equals 2 centimeters, bottom equals 2 centimeters, left equals 3 centimeters, right equals 1 centimeter. Which is going to look a little bit weird, but it gives you the idea. And now the final thing that we're going to cover in this video is how to create a table of contents. So once you've got some section headings to feed into the table of contents, which we have, you can call it wherever you want it to appear using the command, very simple, \table of contents. And that will print the table if we hit recompile again. And that looks nice. Now, this is all very well and good, but any Google search could have told you how to do this part. And it's not very fancy, and we want it to be fancy. And if we're going to go to all the trouble of making a PDF, then we also want clickable links in our table of contents, so that we can just skip around the document as we please. So in the preamble, let's call the hyperref package using \use package, squigglies, hyperref, and then hit recompile. And you can then hover over the links in the table of contents and see that it's referencing the different sections. And I'm sure that you're going to be very unsurprised if I tell you that there are many, many more options than this. So what we can do is access some of them using \hypersetup, and then we put all of the different arguments in the squigglies. So if you wanted to make the links more obvious by making them in colour, then you can add color links equals true. And then to set the link color that you want, you can use link color equals blue, say. I mean, these are not the only options, but at least if you want to set them all to be hot pink, now you can. So that's the end of the first tutorial video. I hope that this helped you to see that LaTeX is actually not as complicated as it first looks. In under 10 minutes, we've just created a basic document and added a few little flourishes to make it even nicer than the default one. If you found this how-to video helpful, make sure to subscribe so you don't miss the rest of the series. In the next video, we'll be adding some equations to this template and learning how to make math sexy. Well, on paper anyway. Feel free to share it with your friends, and if you have a favourite package you think should have been included, or a topic that you really want to see next, let me know in the comments down below. Thank you again for watching, and I'll see you in the next one.